So, ladies and gentlemen, today we are going to finish up our 4-1B notes. On this one, it looks like we are given a graph and we need to write the function, which is kind of the converse of what we did yesterday, where we were given the function when we had to graph it. So today we've got a graph and we have to write the function. So we are going to do this in standard form. Standard form has f of x equals, this is not standard form, this is vertex form. A, which would be a stretch or compression, x minus h, which would be a shift left or right, plus k, which would be a shift up or down. We can also have a negative out here, out in front here, which would be a reflection over the x-axis, or a negative in front of the x here would be a reflection over the y-axis. So let's see what all of this we've got. So it looks like to me that our normal graph from over here, our parent function, has a vertex of 0, 0 and goes up. This one here does not have a vertex of 0, 0. So let's see where it has gone. So it looks like from 0, 0 it has moved to the left. So let's see how far it has moved to the left. Looks like left 7. And then it also looks like it has moved up. So we are going to have a shift up. And up 1, 2, 3, 4. Shift up 4. Sorry, this was a shift left 7. And then our parent function opened up. This one is going down, which tells me we have a reflection. This reflection made our ups go down. So let's flip back over here and see which one of these two reflections makes our ups go down. Oops. Okay, it looks like this one here is when our ups go down. So this is a reflection over the x-axis. So we have a reflection over the x-axis. Okay, so we can see from over there that if we have a reflection over the x-axis, the negative goes out in front. So, there are too many papers. My negative is going to go out in front here. That A is for a stretch or a compression. I don't have one, so I'm going to get rid of it. Got a negative there. F of x and x will always stay. My h gets replaced by my right or left. Since this is a left, and inside the parentheses it does the opposite, it's going to be a plus 7. And then my up and down does what it says, and it goes up 4, so it's going to be a plus 4. We probably should have said what our vertex is. Our vertex on this is now at negative 7, positive 4. And notice from your vertex to your equation, the x value changed signs, the y value does not. Okay, so write the function. This is the function. So this is your answer right here. Okay. It didn't say to do this, but we are going to do the domain and range. Okay, domain for any ever parabola is negative infinity is less than x, which is less than infinity, or all real numbers. And the range is either y is greater than something or y is less than something. And remember, that thing is always the y value of your vertex. So my y value of my vertex, I should do it in the same color. My y value of my vertex shows up on the vertex at the end of the equation and for domain. Since this one goes down, all the numbers are less than 4, so it's going to be less than or equal to. Does this have a minimum or a maximum? Well, this one opens up, this one opens down, so it has a top, which is a maximum. And the value of that maximum is always the same as the y value of your vertex. It's also in your range. It's that 4 again. Now this next one, it opens up, so I don't have a reflection. Does it have a shift right or left? So from 0, 0, if this is my vertex, did it go right or left? No, it did not, so I don't have any shift right or left. Don't need that. Did I have a shift up or down? So from 0, 0, did I go up or down? Yes, I did. Looks like I have a shift up of 2. And now my normally we have our pattern goes over 1, up 1, over 2, up 4. Well, what's this one do? It goes over 1, that doesn't go up 1. It goes over 2, up 2. So it looks like this is a half, and it looks like this is 2. Well, what can I multiply 1 by to get 1/2, and what can I multiply 4 by to get 1/2? If I multiply them both by 1/2 or divide by 2, that would give me these two numbers, right? So what that tells me is that I have a vertical compression of 1/2. And let's test it. If I go right 3, I should go up 9, but with a vertical compression of 1/2, 9 times 1/2 would give me 4.5. So does this go right 3, up 1, 2, 3, 4.5? Yeah, pretty close. So vertical compression of 1/2, shift up 2. Do I have any reflections? I can't tell from the graph. So we're just going to start with this. So I've got f of x. Remember, that's another name for y. There's no negative here because I don't have a reflection over the x-axis. But this is where my stretch or compression goes. Do I have a stretch or compression? Yes, I have a compression of 1/2, so that goes in front of my x. Then I have an x. Remember, in with the x is right or left. Do I have a right or left? No, I don't. So I can just close that parenthesis because I don't have anything right or left that goes in there. And then after that, I have an up or a down. Well, it looks like this is 2 up, so it's going to be plus 2. Then, even though it doesn't say it, we're going to do domain and range. So domain and range. I want you to pause it and try to do domain and range on your own. Okay, did you know that domain was going to be negative infinity is less than x, which is less than infinity? Hopefully you did, because that's domain for every parabola ever. So we've just given you some test answers right there. Any time ever we ask for the domain of a parabola, it's going to be negative infinity is less than x, which is less than infinity, or all real numbers. The range on this one, since this one goes up, it's going to be greater than or equal to, and then it is going to be the amount that I shifted it up or down, which is also the y value of our vertex. We didn't write that, the vertex. I keep forgetting that. I apologize. What is our vertex on this one? Well, it didn't go right or left any, but it sure went up 2. Okay. And then next, does this graph have a maximum or a minimum? Well, since those arrows point up and they go up forever, there's no way it has a maximum. It does have a bottom though. This is the bottom, so it has a minimum. And that minimum is the y value of my vertex, which is 2, which again can also be found at the end of the equation and in your range. Okay, last thing actually. This is going to be a nice short little notes day. Okay, so it wants us to find the equation of a quadratic in vertex form. So vertex form is what we got from page 1. Okay, so on vertex form, we have an a, we have x minus h squared, and we have plus k, right? That was vertex form right here. Vertex form. This is something you're going to need to remember. So this is vertex form. So it tells us that the vertex is 1, 2, and a point on the parabola is 2, 5. So that's the information that I have to work with. So what we are going to do is first, obviously, we are going to use vertex form of a parabola, because that's what it told us to do. Okay, it says vertex form, so we've got vertex form. Next, let's figure out what we can do with this information. Well, if you remember right, over here it says for any vertex h comma k. Well, that tells me that the vertex is h comma k, and I have a vertex right here. Okay, well that's cool. So my vertex is going to be h comma k. So what I can do here is I can replace the h and the k. I'm going to color code this because that's how I roll. We're going to replace the h and the k with the numbers that they gave us for the vertex. We're going to replace the h and the k with the x and y that they gave us for the vertex. So whatever they give you for the vertex, those are the numbers that are going to replace h and k. All right, so I've got f of x, which will not be replaced, a parentheses, x will not ever be replaced. Okay, so I left the h out. The h is going to be replaced with a 1, and the k is going to be replaced with a 2. Now notice, inside my parentheses I had a minus sign because that's what the equation has. So it starts with a minus sign. If this had happened to be negative, then it would change to a plus sign. Same here. This is a plus sign. If this would have happened to be negative, it would have changed the sign. But you keep the sign of the original equation, which is what we were given over here, unless they have a sign change, and then we'll change it. Okay, so far we've replaced h with the x value of our vertex and k with the y value of our vertex. Okay, then we haven't used this 2 and negative 5. It's just a random point. Well, do I know that I have an x value, right? I have an x value and I have a y value or an f of x value, because f of x is another name for a y. So I'm going to put y there also so you know it's both. So now, can I replace my x with this and my y with that? I sure can. That's going to be my next step. And honestly, you could do these two steps at the same time, but for explanation's sake, I am going to do it in separate steps. So now we're going to replace the x and the f of x, or y, with the x and y values of the given point. Okay, so what they gave us as a point is what I'm going to use to replace the x and the f of x. This is getting so colorful, I love it. Okay, so is my f of x going to stay? No, it's going to get replaced with a negative 5. My equal sign is going to stay. A, do I have anything over here that replaces a? No, so it stays. Do I replace the x? Yep, it says replace the x with the x value of the point, so that will be 2. Bring down my minus sign. I've already replaced this 1, and I've already replaced this 2. So now that I've replaced everything that I can, I need to do the math. Okay, so after all that replacing, we are going to solve for the only letter left. Solve for the A. And to do that, whoa, that's a big U. We are going to use PEMDAS. So now let's do some math. Put all those pins down for a second. Okay, bring down the -5 because it's all by itself. 2 minus 1 is 1. So PEMDAS says parentheses, so we did parentheses first. Now it says exponents, so we're going to square that. 1 times 1 is 1. If that number is anything other than 1, it will change to a different number. Okay, so now if I do 1 times A, that gives me 1A. So we can move that to be a coefficient. Okay, now I'm going to switch this around and try to get A by itself. So how would we get A by itself? Well, to solve, we would subtract 2 from both sides. So we would have -7 equals 1 times A. And I hope you remember from geometry that, or Algebra 1 or whatever, that you don't need to divide by 1. Okay, so -7 equals A, or you could say that A equals -7. Actually, I'm going to write that in a different color. You could say that A equals -7. So now I know all my letters that I need. So my last step here is that I need to rewrite this with my A, my H, and my K replaced as numbers. The only thing that get to stay from this original are f of x and x. So we'll have f of x equals, the A gets replaced. Our A was -7, parentheses, x. Okay. Our H gets replaced because that's part of the vertex. Oops, I forgot my minus sign. Minus. My H, back from up here, part of the vertex, my H is 1. And then my K, back up there from the vertex, is 2. So that's going to be a 2. Okay, so you replace A, H, and K, leave the rest, and that is finished. Seems like it takes a long time with all that explanation, but once you do it yourself, I think you'll find it goes a little faster. Good luck on your assignment. Let us know if you have questions.